Hi, I'm Glenn Thacker. Today I built a circuit from the Snap Circuits Projects Guide, but I added an on-off switch and connected jumper cables to the microphone so I could have free movement to demonstrate the effect that sound causes by vibrating the membrane of the microphone to add resistance to a circuit. The load of the circuit is a lamp, and when additional resistance is caused by using sound, the lamp will either fluctuate along with the sound, or if the sound has enough amplitude, will turn the lamp off completely until the capacitor takes a moment to reach enough capacitance to allow the electrons to flow. I used two battery packs in series to produce a power source of 5.22 volts. The lamp in the circuit is rated for 3 volts at 0.2 amps. There are two transistors connected in series, an NPN connected to a PNP transistor by a 100 ohm resistor. We end up with two circuits in parallel, and if I remove the capacitor, or any part of the outer circuit, instead of being left with an open circuit, our first circuit continues to allow electron flow, powering the lamp and removing the switch. Closing the circuit at that connection with a jumper wire would show that the circuit is still complete, with current reaching the base of both transistors and powering the lamp. But the second circuit added the capacitor with a resistor to further dampen the flow, along with the microphone, which added enough more variable resistance to slow down the flow of electrons enough to dissipate the full charge of the capacitor, allowing for a pause as it once again builds a charge sufficient to pass on to the lamp once more, and also demonstrates the use of the PNP transistor as a switch. As long as power is flowing into the base of the PNP transistor, that switch remains on until enough resistance from the microphone and the parallel circuit reduces the voltage and turns the switch off. A small positive charge to the base of the NPN transistor allows electrons to flow from the emitter to the collector, which creates the movement of what is called conventional current, but in actuality is the opening of spaces or holes in the molecular structure of the conducting material as electrons flow in the opposite direction. In this circuit, the two transistors work together in series to form a complementary output. This can now be used in push-pull amplification or other tasks and applications requiring positive-negative voltage swings. The lamp is rated to run on about 0.4 to 0.6 volts, and using Ohm's law after adding my resistances, I come up with about 0.48, so that's right in line. But when it comes to all the formulas showing how the transistors are working, proving it mathematically, I'm running into quite a bit of difficulty and hope to return to that in future videos. But for this demonstration, I wanted to demonstrate how those transistors could work together with the NPN transistor amplifying, and then using that microphone to turn the PNP into a switch to turn off the circuit. Thank you.